I'm pretty sure Shy is a bot and he's just pasting URLs that we don't see. Could only see the text. Yeah, well. Set X range. What's it doing? Add point. Why do I have a black window? Because definitely weird. X9. Going to change this, I guess. Let's make it 100 and 100. That should be visible. Still nothing. Oh, I'm not adding it. Why? Stupid. Oh, I'm not adding it. Why would it even have a layer? This thing has a layer. No idea what scuff is. So I guess no. Guess my plot needs a layer because I want to be able to add a point later on while it's running. No. No, I have to look it up. Yeah, doesn't seem to be related to me or drawing with Cairo. I still don't understand what it is. I'm going to add a layer here. No, I'm not. I'm not going to. Now, okay, this is nonsense. I suddenly realized that it is nonsense. And the reason is that I can Google it again. The only thing I get is music related, and then it stops already. To check your spelling, basically. Quick one. Nothing. It's not there. No such thing as a scuff method. I'm just passing the layer, I think, to the point. To the add point. Oh shit, yeah. I'll have to cast it to layer. Region pointer, I suppose. Kinda stupid. Damn it. Dereference the unique pointer. Cast it to layer region pointer. Now we can call draw that, I think. Layer region pointer. Draw to region. This one. Better. few arguments. Yeah, there's my point. Oh, I know that one. Fast inverse square root. Yeah, that was a trick that John Carmack used. But now you suddenly spell it with a C. That's maybe why Google couldn't find it. And why would I have to implement that? What's your original question? Is you if I wrote it? Nah. We don't live in the days of Quake 1 anymore, anyway. But yeah, that was a nice trick. I know about that one. Just didn't know that it was called the SCUF method or whatever. Make. Let me see. I have a point here. I wanted to make a. I want to change the style a little bit. Also, always get red. It's kind of nonsensical, maybe. Oh, I can't even pass that. Oh, what? Yeah, nah. Well, I guess I can just pass something else. Little green plus. Okay, yeah, the point was I wanted to be scaled to the axis. I'm gonna have to change this black back to white, probably. Otherwise we don't even see the axis. And then let's say I'm going to draw the 0, 0. It should appear there. Might as well use 1, 0 because I can see it. At point 1, 0. Yep, now it's here in the corner. Oh, I see it. It should have been there. So how do we convert that? Guess from this rectangle and the X and Y range. Now what I'm passing is in this coordinate system, isn't it? Yes, so we have to begin with moving the origin to this point, which means subtracting x min and y max. At point, let's do the plot thing. Tell. I need a geometry of the plot area. Which is this. Plot area. Well, it's easy. You know the word geometry? They use it in Unix for, say, the window offset and size. That's what it is. It's a rectangle. And in this case, it's this rectangle here that you see. So the axis rectangle. And now I have a point called, say, 0, 1, and I want it to be drawn there. So you have to convert 0, 1, or the other way around, 1, 0, to whatever these coordinates are. And the only thing I have are the coordinates of this rectangle and the min and max of the axis. So the 0, the 10, and the minus 2.5 and the 2.5. So how do you go then from that to these window coordinates? Well, as follows. Step 1, you subtract the minimum of the x range. So something like x range and then the minimum of that. But I have no idea how that compiles. Where is my x range? Well, we are in plot. And plot does have a range variable. So I can get a range by filling in the x-axis here as coordinate to this array. So we had a range, it's an array, x-axis. X-axis is defined as 0 in plot area, also in namespace plot. We are inside namespace plot, so it doesn't know what this is. And now I get a range back. Range is this type, and the range is defined as something running from min to max, and I want to get the min. Well, it's private, so we have to use the accessor. Go back here, dot min. So now we do x minus becomes, so we subtract from x the minimum value of the x range. Same thing for the y value. So that would be the almost the same, but then the y-axis and actually the max value. Why? Well, because the min value is at the bottom here and we want to move it to there. So if now I would fill in the number 0, 2.5, then that's what we're going to subtract, and so we end up with 0,0 for this point here. Well, that 0.0 then has to be added to this offset from this corner to there, which is the offset of the geometry of the square here, rectangle here. So we get x plus and then g dot offset x, that's the one corner, y, offset y. The g is the geometry of the plot area thing that I pointed out. However, this still doesn't work because this would work for that corner, but not for the corner on the other side, for example, because this would be 10, minus 2.5, and then we subtract the 0, that's still 10. And we subtract 2.5, that becomes then minus 5. And then we have to end up here, which means that the 10 must be converted to this distance. So we have to divide by 10 and then multiply by the width and then add that to this point. And then for the y, it's almost the same thing, but then somewhere a minus sign gets squeezed into the mix. Try to think about that. Let's do x is x minus that divided by the size . This now runs from 0 to 1, and this runs from 0 to minus 1, I guess. I have to add, yeah, just put a minus in front of it. So do the other way around. So now both runs from 0 to 1. And then we first have to multiply it and then add that offset. So x must be multiplied with the width of the geometry, and the y must be multiplied with the height, and then the offset, and then it should work. Yep. Intrusive pointer is the name of a smart pointer that Boost has. It just means that the reference count is part of the class. So you have to change the object for the intrusive pointer to work. Okay, I guess this is 1, 0, right? Oh, I can show you. You're talking about intrusive pointer, this one. So it's a smart pointer, a reference counted layer. So it's the whole thing has a size. The intrusive pointer itself, a boost intrusive pointer has a size of a pointer. It is just a pointer. And then the reference count, meaning that there is a reference count, and if you destroy the last smart pointer to that layer, then the layer is destroyed, right? Deleted. And in order to know that it's the last one, it needs to keep a reference count of the number of smart pointers. And they are part of the layer itself. So you go to layer, then you see that the layer is derived from AI ref count, which is then adding the reference count. So that makes the size of layer a little bit larger, because AI ref count is containing an integer, or an atomic actually. That's the size of the ref count, just an int. And then the magic is that if you use boost intrusive pointer, then it's going to call these functions. So they must be defined as well, but well, I have everything defined in the base class, so I just derive from AI ref count and that's it. The rest then automatically works. Plus stuff for myself. Inhibit and allow deletion. And I added stuff like is it unique, which returns a fuzzy bool. Just my stuff. Yeah, Merry Christmas to you too. I could put on Jingle Bell music, but I like the running water sound. So why would we? Now, yeah, so this taught us how to do the conversion. And then I can maybe also now write a function that will simplistically draw a function. Just straight lines from point to point. And then I can have a look at the Bezier curves. How to fit that, which is a very interesting topic. Might as well make it the Christmas special. I've seen a lot of questions about it from Stack Overflow yesterday. People wondering how to do that. Let's give this a test with just a parabola to VI, blah, 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 blah. Turn the grid on, remove that. How do we turn a grid on when we don't know its plot, I think? Let's plot here. This dot grid. It's not just setting a grid color, I think was a trick. Set it to orange again. It's not It's not highlighted though. It's a second argument of plot. That's a plot area style, which has an access color. No, I just have a grid. I must put a grid style. What? Grid style just has a color. Grid is grid style. Oh, like that. Okay. So we must do grid. Grid is, and then dot color is standard orange. No, that's color. Now let's make a parabola, something like. How do we do that? Well, it means we have to add a lot of points. For double x is 0.0, x is less than 10. X plus is 0.1. X, comma, and x times x, of course. Let's see, that was a bit big. I want it to be 2.5 when it is 100 at the moment. So I have to divide by 40. Or I can put it upside down. And then make it, let's say, bigger. So divided by less. And then, let's say, add 2.5. Try that one. Oh no, that was not what I wanted. Oh, that might also work, but I wanted to have it run like this. It's 4 times smaller now, so let's make this 4 times smaller. That should work. Yep. Yeah, I want to draw lines, I think, instead of just the crosses. How to do that? Make a vector with points in it, and then just say draw it. Draw all of it. I probably need more room anyway. So, but now it runs from 2.5. I could also just make the axis different. So let's make it run from -5 to 5. So we can just change the Y range here. Yeah. So the plan is that I want to use those cubic Bezier curves to fill in lines from this point to that point instead of using a line. It's like kind of ridiculous, but the idea is then that the Bezier curve must fit a parabola perfectly. So then you get an absolutely perfect parabola, even if the interpoint, instead of having just straight lines. And that the only reason I put the points so close together now is because I do want to draw this with straight lines and then still get a nice figure, because we have to compare it with well, what we want to get in the end. So let's start with hacking something together that just makes lines. So that would be, well, at least the interface, and I can make the interface already. So we could put all these points. Let's say I'm making a vector with data points. Okay, I'll just call it point. It's not a draw point, but it's just a real point. And then we do points and place back. So that is an in place constructing the point every time it is inserted, appended at the end by passing an x and a y coordinate. So I have to write a point to begin with. Let me just begin with that here. AVI point name is Bezier window. Class point. What's a header? Pragma once. And the thing is double x and double y. And we have a constructor point which takes a double x and y and remembers it. No doubt we're going to need the accessors for x and y. No, that isn't a data point, then what is? So yeah, that kind of should work. Except now I want to plot it at curve. Also pass a layer, and then we pass the whole vector here points with some point style. No, I don't have point style. Just lines. Be a line style, I guess. Yeah. The line style, whatever the line style is. Pretty sure I have a line style though. Color. Yep, there it is. Line style. And the line style is defined as something with a color and a line width. Well, choose the default. Yeah, then we have to add this to plot. Looks a lot like the add point. Except that now we are taking that as argument. Let's go to plot. And then add void. Add, what was it? Not a curve. So we get a layer and then a bunch of points, and then a line style. Sure. Now we have to run over all the points, I guess. I'm just gonna make this a one big curve. I'm using Arch. Options. You can just use cairo to draw the whole curve, and then the rectangle that it must be exposed is the whole, well, basically everything then. As large as the curve is. Or I can just use smaller rectangles Or some, well, I could use a rectangle per line, just, you know, add a lot of lines here, or maybe draw a few lines and then use that as a curve. Just split a curve into multiple curves, basically. Each with their own rectangle. Which would make my total curve a multi-region. It's never easy, is it? I guess I should start with lines, because otherwise I have to code something else first. It's a lot of lines, so. But okay, we'll just start with it. There's a lot of line pieces, and I have to remember them, otherwise they disappear again. So, kind of like the points here, but then for line pieces. Why the hell do I have a points without an underscore here? Points. Points and labels. It's just used to to keep them alive. Because if I destroy it again, then it stops being drawn. Same thing here, to place back and then use that, but by placing it back in the vector, it's kept alive. Right, so next to points, and I need lines. Let me just, I have line. Line is constructed from a geometry and a line style. I do have a line style. So this is going to be... Oh, you got totally lost now. I'm no longer where I want to be. Let's go to this window. Vi plot.cxx. Plot. Yeah, let's run over all the points. And then I need 2 points to draw a line. Kinda need a previous point, which is annoying because this is reference. Can you make a copy of point? Point is just a shape. Shape is a rectangle, and the shape style is kind of big. Could make, no, it's not really big, but could make a copy, but let's pretend that we can't and just keep pointers to it. So I'm gonna have a point const a pointer previous point. It does not exist yet. So then if we have a previous point, then we have 2 points. Otherwise we don't, but we remember the previous point by getting the pointer of my point. If you get a point. And now here inside we have the previous point and the current point, so that makes a line. Yeah, I need a ridiculous rectangle for it. Just lines underscore dot and place back, make unique, draw line. The reason I'm using make unique here, by the way, is because I'm using pointers all over the place. So I'm having pointers to my line. So I just store lines instead of unique pointers. Yeah, then the address of the lines are continuously changing, which is not a good thing. Because if I store the line directly in the vector, and then you add an element to the vector, then the vector might be too small. So then it gets resized, which means that it might not fit in a memory block that it is in. So that means that it would allocate a new memory block and then just move all the lines over, thereby changing the address. But by doing make unique, I'm just allocating each line separately, and that it stays there, so the address never changes. It's kind of, I don't know, not very optimized stuff, but I'm not really worried about speed in this case, I think. Not that much anyway. Yeah, make unique and then constructor arguments. So the constructor arguments for my line are a geometry and a style. Geometry, comma, style, and the style I have here, that's the line style. And the geometry is just a rectangle. The rectangle is constructed from two offsets, a width and a height, which is the ridiculousness of it all, because, well, let's use the previous point, x, comma, previous point, y. That works, right? My point. This point, other point. Nobody knows where my point is. But now we do. This point, x and y. This is inside plot. Do I have a point inside plot? Of course, no. Cairo window. This one is in namespace draw. And this one is in namespace utils. If at all. Yep. So we get the right point here. Run over all points. If we had a previous point, then add a line existing of starting point, previous point, comma, and then we have to pass a stupid width here. The line is not going to be long enough, so let's start our current point x minus the previous point x. That would be the width, and then of course point y minus previous point y is then the height. Which then defines my line, and we have made it alive, and then I still have to draw it, add it to the layer. Should be able to do lines back here. So the lines is a vector of standard unique pointers to lines, and I do have a draw that takes a standard unique pointer. This one. And that then is used, but only if that is a layer region type, aka a layer region. So it must be derived from a layer region then. What my line is, right? The point wasn't, but the line is derived from layer region. Yay. So that should work. Now, I'm starting to get a feeling that this is already enough. Let's try to compile it. Unknown type name point vector. That's just a missing header, I guess. It's a new class. Unknown line style. Did you mean draw line style? I guess I did. Make. Core dump. Search in width and height must be larger than 0 field. Oh. Let's do the plot thing. Oh, right. And really, yeah, I guess. To sort these things in order, that's kind of stupid. Well, my X becomes larger all the time, but why doesn't? Just two different possibilities here. Doesn't matter, but almost always X, the previous point to X is less, so let's do it like that. And the height is then, well, yeah, well. It's not crashing, but we don't see anything. Why is that? Damn it. Oh, yeah, I'm not scaling it yet. I was thinking about using the Cairo matrix, but should I do this draw here? Calls draw region get, calls draw on the layer region. Does it save a translate? Okay. Hmm. Hmm. Yeah. Definitely thinks that the previous point exists here, starting at 0, 0. And this is throws from the wrong corner to the wrong corner. Why? Well, I mean, that's because of the absolute value and stuff. I guess assert is wrong in the rectangle, or it just should not use a rectangle for the line. The latter makes more sense. Oh, right, I see it. Well, let's fix half of it. We still have these things. Yeah. Using a rectangle is just kind of stupid. So let's use yeah, I don't know. Turn. Fixed. How can I learn CPP? Well, you begin and then you don't stop ever till you die, and then you still don't know it. I'm just kidding. But except about the beginning. Start coding already. No, this is a parabola. Totally happy with it. What the? Okay. The coughing never ends. I know, it's gonna cost me all my viewers. Bleep. Stop. Weg. Kan. What to do next? I want to do a Bezier curve. Do I have any interested viewers who like mathematics? Oh, you do. Okay. Well, let me think out loud about Bezier curves then. So the idea is as follows. If you have a point, I did write something on a paper. Where's my piece of paper with this? Oh, there it is. Okay. So we have point P0, and we have another point P1, and we want to draw a line. I mean, we want to draw a graph through it. Oh yeah, very stupid, so we just draw straight lines. So, yeah, that's going to be the line, right? And at the moment that we are somewhere halfway, so we're drawing that point here. We're going to say, well, you know what, let's draw it, well, it's going to be parameterized, right? So by with t. So really this distance here, I can't type anymore. This distance here is the length 1. Well, it's not really, it's 0.1. The point P0 and P1 can be anywhere, right? They can be reversed, vertically, diagonally. But yeah, there are just 2 points with X and Y coordinate. And I'm too lazy to draw diagonal lines. It's my ASCII art at the moment. But we are going to have a parameter t, which runs from 0 to 1. And at the moment that t is 0, we want to be in P0, and at the moment t is 1, we want to be in P1, and we want to do everything linearly. Therefore, we can express this as a function of t, where f is then also a two-dimensional point, right? This is xy coordinate, point 0, 0.1 xy, and f is also a vector xy. And we are going to say that is equal to P0 times 1 minus t plus P1 times t. Totally linear. And if t equals 0, then this drops out because t equals 0. And 1 minus 0 is 1, so for t equals 0, the f is going to be equal to P0, and for t equals 1, then this drops out, and we just are left with just P1. So if now t runs from 0 to 1, then the point f goes linearly to the other side. Yay! Note that this can also be written as P0 plus t times P1 minus P0. Which makes almost more sense because, well, we start in P0 and then when t runs from 0 to 1, we add the difference so that we end up with P1 by the time that t equals 1. That's the same thing. And we can also write this as 1t, which is a row vector, times, okay, I need a matrix. Just have to steal matrix for the other readme. Which is a matrix backpropagation. Totally has matrices. Let's steal this stuff. And then straight line. And then closing, and then everything again. This, maybe I should just copy the whole thing. Move this out of the moving control, delete, paste, delete, and then let's put in here 1 and a 0 and a -1 and a 1 with more space. Yeah, really. That's a matrix, so blah, 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 blah. And then we get here a P0, really, and a P1. Which is just the same thing again, but on a matrix form. You know, you multiply matrices. If you multiply this matrix with that, you rotate this thing 90 degrees, so you get P0 here and P1 there, and now we multiply it with the first row and we add it. So this is P0 times 1 plus P1 times 0, which is P0, yay. And this is then minus P0 times -1 plus P1 times 1, so that gives us minus P0 plus P1, or P1 minus P0. So we have now those two multiplied is a vector with P0 here and P1 minus P0 here. And now we multiply that with this, so we rotate this vector again. So we get here P0 and here P1 minus P0, and then we multiply that and add it. So you get P0 times 1, that's that thing, plus T times P1 minus P0, which is that thing. Just a different way of writing it. I like matrices. Okay, so next thing is, of course, that we go to 3 points, because this is a bit too simplistic. So P0 P0, and we have we're going to do something. Namely, we are in P0. For t is 0, we are in 0. Yeah, but now we're going to do something and then end up in P2. So move, and then we end up in P1 again, and then we continue. No, I have to make diagonal lines. There's no other option here. Okay, that's enough. That's P2. Are we going to interpolate over both lines? Let's use U here. So this one was running over T, so denote that like that. This one is now going to run over U. So when U runs from 0 to 1, then we move linearly to P1. Purely depending on U only. So hey, we might as well write this point here as actually f function of U. And this was then f as a function of t. Yes, that's that point. And then here we have f as function of v. And now that means, of course, that if v is 0, then we are in P1, and if v is 1, then we are in P2. Can we write that down? Fu. Can you guess what it is? No? Really not? Too bad. What was that thing? So we run, if u equals 0, then we are at P1, and if u, and so on. I won't add the matrix, but I do add this one as well. Yep, times u. This is a fu, and now we get an fv. Lo and behold, that one run from P1 to, and we use V, and we run to that one, and we were using V, and still that one, and still V, and still 2, and still 1, so yeah, exactly the same thing, but now with P1 and P2 and using V instead of U. And now the big trick. Let's define a G, which is a function of U and V and W. Which sits in between these 2 points. I can't draw a line here. This ASCII art is not working. But somewhere here between these 2 points, between FU and FV, there is another point here. And yeah, you know, straight line here. And that is running, interpolating this thing using W. We call that G or W, but it's also a function of U and V. And in case the missing line is confusing you, this means that if W is 0, then we are in FU, and if W is 1, then we are in FV. Yep, W. So, absolutely the same thing. That's FU. I like this function, really. FU. Can't get enough of it. Hey, little Dick, you just missed nothing. FU, it's all on the screen still. So there must be that, right? Yep. I'll even indent it for you to make it more clear. So if W is equals 0, then this is 1 times FU, and therefore we are in FU. And if W equals 1, then we must end up in the other one, FV times W. And if you write it out, which I won't do because it's a half a page. In the end, which one is interesting? So you can either concentrate on the point differences or on the parameters. And none really teach us anything. I'm going to go with the point differences. So we can write this as P0, P0 plus U plus W minus UW times P1 minus P0 plus WV times P2 minus P1. Right. Trust me, if you write this all out, then you get that. And we can verify it, namely if both W and U are both 0, then we should be in P0. So if W is 0, then this drops out. That drops out. And U was 0 as well, so this drops out. And the only thing left is P0. Yay. And if W is 1, then we must end with, well, I don't know, just fill it in and you see that it's the same thing. So if W equals 0, then you just, and U not, then you just end up with FU. That's P0 plus U times P1 minus P0, because W is 0 and W is 0, yeah, which is exactly the same as this. Oops. So W0 gives you this. W1 gives you that. Fill in W1, end up with that. And then we can fill in T for everything. And then we get P0 plus 2T times P1 minus P0 plus T squared times P2. P2 minus 2 times P1 plus P0 time. I'm just copying this on my piece of paper, which we can write again as a nice matrix. So I'm going to do that. 1, 2T, T squared Something like that. Okay. Yeah, so can already guess what the next one is, I think. My guess is 1 3t 3t squared t to the power 3. And this is probably all zeros here and all ones here, and then this is negative, and then this is a 1 at the bottom again. Yeah, all ones. Maybe 1 minus 1 now I think about it. No, I don't know. Anyway, and on the row below that is of course 1 3 3 1. The minus signs are maybe a little bit less clear, but definitely, you know. And if not, then we have to work it out, if even that is needed. Right, now I think again. The most interesting thing about this whole story is that we don't have an x and a y axis. Not really. We just have points. And this works as well if the points are vertically positioned, or if we I could even move the P2 all the way to the other side, or wherever I want to. We just have points, and then we interpolate more or less linearly between those points. But you could say take the derivative of f relative to t, and then you get that, which by the way is then the derivative between quotes at t equals 0. Yeah. So the derivative, whatever that is, in p0 with respect to t equals the vector from p0 to p1, which is immediately clear how to interpret that if you draw that vector in p0. So we have p0, we draw a vector from p0 to p1, which is then exactly that vector, p1 minus p0. That gives us the speed and the direction in which we move at the moment we leave p0. And it's a constant because that speed remains the same. So just go linearly in the same direction with the same speed with respect to delta t, right? And in this case, the derivative at t equals 0 is 2 times p1 minus p0 plus 2 times t times whatever, but t, fill in t is 0, so that drops out. This drops out because it's a constant, and we end up with the derivative relative to t, derivative of g relative to t in the point p0 equals, or is linear with p1 minus p0. Times 2 though. So yeah, we're going a little bit faster than you would expect when you want to end up in p1. It's maybe not weird, because in the end we have to go all the way to P2 and not to P1. So if the 2 wasn't there, then we would have to accelerate later on just to make it to P2. So this is more like a Taylor series. You have a t and a t squared and a t to the power 3 and so on. And it gives you the Taylor series around P0. Yeah, so in first order we move in the direction of P1. But if you continue, then there is a new factor which is depending on P2 as well. Now this everyone will recognize as something having to do with this second derivative. Most notably if P2 is on the same line as P1 and as P0 and P1. Then we don't have a bent curve, it's just a straight line. So then you want this to be 0. But it is only 0 when a P1 is in the middle of P0 and P2 in that case. So only if this distance is the same as this distance and they are on the same line, then this will be 0. What does that tell us? That tells us also a little bit about P1, I think. That's P1 really should be in the middle of the path. If you want to interpret it like the second derivative here. And if that's the case, then 2 times that difference is exactly the same as 1 times P2 minus P0 in that case. So maybe that's what we should work with. It seems to me that it makes more sense to, let's say, talk about the stuff around P1. So we have, this is Taylor series around P0, but I really would like to have a Taylor series around P1, maybe. Yeah, not really. I mean P1 is not a real point, right? P1 is a control point of the Bezier curve, but not a data point. That would be stupid. I think that I see people make that mistake. They see 3 points here and they think, oh, all 3 are data points. Now I want to have a curve that goes through all 3 points. No, you have only one. You have only 2 points here, P0 and P2. And then there's a curve going from here to there, and it's going to go through P1, through P0 and through P2. P1 has nothing to do with it. P2 is just for the curve and for the directions. But if you have a lot of points, and now I'm going to go back, I think, to my nice graph. Let's make a P0 and a P2 on my graph. Let's see. No. Okay, let's say we want to draw a Bezier curve from here to there. Is that reasonable? Or maybe from here to there? Like this? Like this? I think, yeah. 6 seems nice. Now maybe starting in, let's say starting in 3, from 3 to 6. Just a little piece of it, but it got to start somewhere. Now I'm gonna take more till 7, say. Let's say from here till so the symmetrical. So from axis 2 till 7. Now this is a function, of course, but okay. So I wanted to add a point now. See, we can do that. So add plot, add point. Also do the second layer, why not? And then the coordinates, what did I say? 2 till 7. Can't remember. That should add 2 points. Yeah, well, they're green, so maybe I should make them red, because this is hardly visible. Point style, let's make color index 1, that's red. And vanished. They are red points. Now, why not add a label? Text. How do I add text? Well, good question. No, that doesn't work. Already have a Y. Or does it work? What do you think? Why is Y of I don't think so. Anyway, not the second time. What do we want? I wanted to centered left off. Oh, and I have to convert it again. I need to expose some conversion, I think, from the plot. Uh, Yeah, standard make unique, so we have to pass the constructor arguments here of text. And that takes a string, pass x, pass y, and then a text style. And I have text, and then this. I think that's a leftover. The code was commented out. There's now just, I think it's just a dot position of the text style. Text style has a position. Oh. Same thing here then. Centered right off. Still nothing. A web constructor deduction guide for deduction of template arguments text style. Dot position and dot font size. Candidate function template not viable requires one argument, but two are provided. Candidate function template requires 0 arguments. And then another error. It's a template. Those errors make no sense whatsoever. Anyway, it is a template with a default, but you still have to tell that it is a template. Something like this. And then we get the redefinition of the text. Yeah, that's kind of true, right? This text is should also be added. Now I think about it, and it isn't. Let's just call this text 0, text 1. Oh, wait a minute, I did that, yeah, but not here. Okay. Goddammit. Jesus. An illegal instruction. Yeah, I tried to remember when I saw that before. That was a while ago. Nope, I can't remember it. I think it it means something like it happens when. Leaving a function with a return type without returning something, I think. So a missing return. Oh, yeah. In your face. Double. Yes, VI. Blub blub. Return Y. Now there we go. Huge P0 and 1. Very close to my point as well. So we want to have some kind of offset there. And a smaller font size, yeah, the 12. And we had font size, style. Let's see what I have here, man. I have an offset after the font size. Comma offset is well 10. That should work. Dot offset is 10. No, okay, bit small, but I don't know about you, but it feels like, yeah, it moves it upwards, which is not what I wanted. I wanted to move it to that way. Yeah, good enough. Maybe we should have an offset for X and Y separately. Except of course that was P2. Cool. Yeah. Now I think that yeah, you don't really need a cubic Bezier thingy for this one because it's just a parabola. So you can do with a quadratic Bezier. Add a single point, which is probably, so you have the tangent line here, so, and another one here, and then where they cross, that's P1. Isn't that how it works? Could be anywhere on the line though, but then we need no, well, yeah, no, the argument's easy. Yeah, I mean, we know that the control point, wherever it is, so P1, that's the direction in which we lift off. You know? So we're in P0 and we move T a little bit, then the direction that we go into is P1 minus P0. So if P1 is here, we're going to in that direction. So P1 must be positioned such that the line through P0 and P1 is tangent, that difficult word, to the curve in P0. And we have only P1, and the same must hold for this one. So there is only one place where P1 can be, namely on the cross point of these two tangent lines. That's just the P1, period, the end. No other solution. And in order to calculate that one, I would need to know the derivative at this point and at that point. But I want to draw arbitrary functions. So we're going to calculate it from data points. Now the only reasonable thing I can do if I want to have, say, if these are the only two data points that I have, then I don't have a derivative whatsoever at all, I must say. Unless maybe I take it's like 5 threads, so 5 back is minus 3. So here, up there. And then you can gamble that the line through this point and that point more or less is parallel to this tangent line, which is clearly not the case, but if the points are closer together, then that is the case. And I think that's the best we can do. Same thing here, plus 5 is 12, so that's like all the way up, down there, yeah. More or less works, I think. So I'm going to make 2 more points, left and right, which then has to fit, and I have to make that the Y range must run from, the X range must run from, let's say, this minus 5 to that plus 5. So that's to 12, minus 3 till 12. That's my X range. Plot. Oh yeah. What did I say? 2 minus 5. So minus 3 till 12. And now we make 2 more points, which are just helper points. Yeah, I'm so done with this. I know I need 5 points or something like that. Well, let's do that a tiny little different, as in... I. What? Where are my labels? We run from 0 to 10 still. What? Why? Well, that's because of this. Minus 3 till 12. Thank you. But my labels have vanished. X is minus 3, X is less than or equal to 12. Plus is 5. work. I don't see why it would not work. Oh, because I'm destroying them. Yeah, not smart. So they'll have to make a vector. Pretty cool. So if I'm not mistaken, then the horizontal distance is the same. So we go from -3 to 2, that's 5 difference, yeah. And then to 7 and then to 12, yeah. And then we want to draw a line from Q0 till P2, because that's going to be the derivative that I assume in P0. And the same thing here, I draw a line from there to there, and actually also draw tangents to see what the real lines are. Oh, this is stupid. Why would I have to store that here? Can I not add text to... Of course I can. Plot. Should be able to add it directly to plot. Currently we have an add point and an add curve, and I need to add text as well. And add line and everything else. Yeah, we have labels. I can just add a label. Why not? Currently labels are added just here. It's kind of the same thing. Add a label here. Plot add label. And then, well, you just follow the same thing as there. So I'm having a double XY and a draw. Yeah, label style. Do I have that? Label style. I do have a label style. Label style. Okay. Of course you have a label style. Labels per axis? No. No. Just random labels, dude. We have to add a separate. Maybe I should call it text. Do we have text style? Hmm. Yeah. Hmm. Yeah, maybe then not call it text. You could call it so data point labels. Kind of using the word labels still best, I think. Add label. But I don't want to use the label style because I already have that. Yeah. Yeah. So this should draw a line between point 0 and point 2, as well as point 1 and point 3. But still have to add it though. Add line. Plot. Right, how do we do that? Well, need a vector to keep them alive, those lines. Do we already have something to store lines? Totally, lines. So you could do the same as here. Lines dot add place back. Make unique a line. Constructor arguments of line. And then draw the thing that we just created from lines. So how do we construct a line object? Well, that takes x1, y1, x2, y2 in a style. That's easy. I'll still convert it though. So we convert the points and then the line style. And then the points are obviously coming from point, and I think those have accessories. Yep. So that is from dot x, from dot y, to dot x, and to dot y. No lines. Well, my line style must be good because the curve appears. So add line. Points. Points must be good as well, I think, because points is just these points. Oh, wait a minute. Oh, no. Those are not the points that I wanted. I want these points. These are just the whole curve, so 1 billion points. So I think the line got drawn, but those points are so close to each other that it's just not visible. So I'm using the wrong points. Let's rename this to data. It's more curve even. Curve points maybe? Curve points. And I'm going to make another one, which is just called points, and then we have to fill that with these points. Yeah, with points. Dot and place back xi comma yr. Yep. Those are lines. And we're going to assume that the slope of this line is the slope in this point, which might or might not be exactly the case. Probably is exactly the case because distances are the same here. Do I want to draw the tangent line as well or not? Let's see if we can easily change the color. So I want this to be black, say, these lines. And suddenly I want them to be dashed as well. Damn it. Why do I want so much? So we're talking about these lines here with a line style that I just changed. So I'm going to make another line style then. This is the curve line style. And then here we have line style, which I want to give another color, just line color. Oh no, they are black, so that was easy enough. Yeah, you feel it coming. Right, so I need a, if it isn't a double again, an array of double. I could use a vector, I guess. So you just can pass whatever I want. That's silly. Nah, just let's go for the vector. Okay, so line style. I could add a dash style maybe, or just add it here. Well, let's add a vector double dash. And then just after the line 2. If dash, I don't need a style. Where's my style? Style dot dash dot empty. It's not empty. Now we have a dash. dashes. Okay, I'll call it dashes. Num dashes. Dashes.size. Dashes offset. Style. Dot dashes offset. To be it. Double. Dashes offset. Yeah, was it a little bit too C++-ish? Dash lines. There we are. Took almost no time. I suppose I should support drawing lines from point to point, or continuing the line indefinitely until it hits edge here. Because I'm gonna need that here. I want to calculate it manually, of course. That point. So yeah, it's a nasty one. So that means that we have need a new style where I'm gonna say to that before the dash is line width color. It's Kind of stupid that the order has to be the same. Okay, dot. Continue. Oh, that's a keyword. Extend. Yeah, and then some enum maybe. An enum. Where do I get my enums from? Draw, of course. Draw or plot? It's actually plot. Huh? Plot. And then we can extend, I guess. Extend to. Extend from. Yeah, something like that. Line style must have an extend. Line style, this is in bloody draw. What's in the namespace? Plot or draw namespace? Would extend. Specific to this line, I guess, but not really, because I need data from the plot. I definitely need data from the plot. Yeah. Yeah, it's kind of nasty. I mean, the plot in namespace plot is going to have to interpret this line style, but if I add it here, then I add it in line style in namespace draw. So why does it not feel good? Do we have to pass a separate line style? Could add two styles, like this line style and then another line style for the plot. A plot line style. Trying to think of other things, but or maybe it's not a style then. Let's decide that it's not a style because it doesn't fit in its namespace. In that case, it's not a style, so let's remove it from here. I'm gonna have plot extendo. Extend from. And we do it just here, as in, let's say, I'm gonna do it like that, I think. Yeah, maybe. So now we need a plot extend form. That is argument to that function, which means that add line has an argument which is called plot line style. No, yes, well, maybe. No, it's extend, right? So we call it a line extend. And the default value is none, I guess. But it's a bit short. Let's call it extend none. Line extend. Okay, so I have to define that in namespace plot. That would be here. Enum line extend. We have an extend form and an extend to. And then extend none. And just extend, which means left and right and both in all directions. What? Let's interpret these things as a bit mask. So both form into line extend. Yeah, and then we have to calculate here what the new coordinates are, depending on, which means I have to calculate the cross thingy, where they cross the edges, and then replace them with that if the extent is requested. And that I did somewhere, God knows where. Intersection point sounds about right. So apparently the trick is to well, include this header, postponing it as long as possible. I'm gonna have to move this header, I guess. The section section points. Okay, header. Guys, so we make a hyperplane and a hyperblock. I think my hyperblock is the rectangle. It's even called rectangle here. I think it's pretty obvious what that is. X min, comma x, yeah, min, max, min and maxen. So that would be from my range. I have a range. I think I have a. This rectangle takes just two thingies. Hyperblock. What the hell, man? Float type. Do I have a float type? I don't think so. Let's make that double. And hyperblock takes a vector type, which is a vector of float type, n, and then what is vector? A vector is this, which is actually just an array. Okay, so this is basically an array of two doubles, and I want to fill that from my range. I think I have a range underscore. Number of x's range. The range is just min and max. Do you have that here? So that is min, and again a min, and then this must be the max thingy. And then the first one must be the x-axis, x-axis. And the second one, of course, then the y-axis. And then again the x-axis and the y-axis. Because range is an array, one for each axis, so I have two ranges. X-axis is 0, y-axis is 1, so we take the first and second element of my range array, which is just two ranges, one for the x-axis and one for the y-axis. And then this should be good. And the hyperplane here is just a line. It's also called line. And that is hello David, thank you for the Merry. Are you going to Merry Christmas? Mary Poppins. The hyperplane. Hey Post Bunny, I didn't see you there. Also happy Christmas. Hyperplane is constructed from a vector type. Oh, it's a normal. N is a normal and D is the displacement. And I have to convert my thingy to that. So this is a normal, and that's the displacement. I don't think it has to be a unit normal. I can just do whatever I want. We think we have 2 points. Because the normal is the difference between the y values, comma, minus the difference between the x values. I mean, what else could it be? Just kidding. Where's my point? Yeah, anyway, from dot y minus from dot y. Oh, wait a minute. 2 dot y comma 2 dot x minus from dot x. Let's think about it a little longer. The normal is something that should point perpendicular to the line, of course, but then which direction? You know what? I have no idea. What's the best direction here? Up or down? Suppose you have a line that runs from the origin to 0, so to 1,0. Then why would the normal be the y-axis, or why would it be the negative y-axis? I have the feeling that it is the y-axis in that case. So you swap x and y and then you make y negative? No, but then it becomes minus 0, minus 1. But I think it's the y that is negative. So yeah. purely with a on vague intuition, I would say it's of course two. Sorry. Yeah, it's 2 minus from. I mean, to stay positive if you do something useful. I mean, something with something like going in the positive direction. And then this one is then the minus to the x difference, but then minus. I think this is correct. And then D, the displacement of the line, is what again? That's the distance from the origin to the line, expressed in normal vectors. I'm gonna grab a piece of paper and calculate it. Otherwise, I don't know. And axis, y-axis, x-axis, line. Let's check out this is my line. And then this is a from, I mean, this is from, and this is to. Then the line equation is, as I said, this was y and this is x. The line equation is y equals from, why am I using x and y? Let's call it capital X. Capital X is a vector, is from plus t times 2 minus from. Yeah, okay, so the x is from x plus t times 2x minus from x. Y is from y plus t times 2y minus from y. Yeah, let's just multiply it. x times 2, Jesus, now my pen is empty, 2y, why is this pen empty? What does it say? 2y minus 4y. That multiplied with that equals. Should have subtracted that probably. Okay. Now think about it. I did this already before. on Stack Overflow, didn't I? Maybe I should have a look there. Yeah, y is from y plus from x times 2y minus from y divided by 2x minus from x. And there's a minus sign wrong here. This must be a minus sign. Plus x times x, and that is 2y. Y. I know how to do it, but it's gonna take a long time if I do it like this. So let's try to find a shortcut. Gonna look at my article on Stack Overflow, because I can't remember that it was that difficult. Which Stack Overflow though? Yeah, can't find that bag. Back to pen and paper. Yeah, it is simple. So that would be the unit normal. Not even sure why I divided by LD, but I think I can remove that afterwards. And now we want to have, I want to find the distance. No, I want to find the number of ends needed to go from the origin to the line. So I need a line equation anyway. So we have a line equation x equals p0. Well, I'm calling this 2 form here. 2 plus d times from minus 2. And then we want to cross that with sorry, to cross this with s times n. It was simple a second ago. Oh shit. Seriously. So negates the extra thing. Well, fix that. Yeah, so it's a difference between the y with a minus in front of it. And then divided by the length. The norm of n, whatever. And this is what I had trouble with. Oh, yeah, of course. Just a projection. So stupid. Should I call that point? Not dx. 2.x times nx plus 2.y times ny. This is just the in product of the two vector with a normal. In other words, the projection onto the line through the normal and the length of that is my d. Oh, wait a minute, this is already length. Because well, we divided by because my n is a unit vector already. Now, compare that. So x0 here is 2x, and then times the minus the difference between the y values. So that times nx, and nx is minus the difference between the y values, and then all divided by the square root of the difference squared plus the x difference squared, which is also what I had. And then the other one is the 2y, that would be y0 times x1 minus x0. So that is ny times that, and then again divided by the square root. So it's the same thing. But now you got to wonder, if I pass this to y minus from y, that is dy. Okay, going back to the other form here. If I pass this, that is then from minus 2 for the y's, which is minus dy, which is nx. So this is nx times ld though. And this is 2x minus, so that is dx, which is ny times ld. So this is the normal vector times ld, the distance between the 2 points, between to and from. And that means that we scale the whole thing, so the d that we have to pass here must then also be multiplied by, I think, or divided by. That's a good question. I think that has to be yeah, I have to multiply it. So this then must be d times ld. So this is n, but multiplied with ld, because we didn't divide it by ld. And then the d must also be multiplied by ld, which then in turn gives 2x times nx, which is then minus dy. So let's turn that around. It's 2y times ny. Wait a minute, I meant 2y times ny, but I'm gonna use dx. And then we have multiplied it by ld. And then minus 2x times dy. And then from y minus 2y is minus dy. Then 2x, that is just dx. What can go wrong? Yeah, and then you calculate the intersections. Really? And then what? Intersection point returns a standard vector of hyperblock vector type. A vector of vectors. Yeah. Okay. Still not. What the hell, man? Editing the wrong thing, am I not? Editing the wrong thing. Yeah, residual loss. Well, it found intersections with the X and Y axis, but that's about it. Oops. Yeah, what the is wrong here? Ding dong, ding dong, ding dong, ding dong, ding dong. Plots. Same thing, huh? It is the same thing. I don't know. I'm just gonna random try something like negating the thing. Yeah, and that worked. Well, no. Strange but true. The minus sign. No, wait a minute. I'm inclined to not believe ChatGPT. Because what I remember, it's that has got to be a minus sign. Which then probably means that I have to revert this back. But we'll never know for sure, I guess, unless I compile it and run it and it's still okay. What the hell? Still okay. Nevertheless, which represents which? No, looks fine to me. So the from is the from, and the other side is literally like, well, the other side. Otherwise, it would have drawn the line like that way. So that seems to have worked. And depending on the style. No, it was not a style. The line extent here. So that's it. Hello, owl. Not working. Yeah, yeah. Still not good. At least there's a dash missing here. So it seems like it stopped at the axis here. That is strange, because I thought I had a none or not. If I didn't have none, then what the hell? I needed a little bit bigger. Yeah. So this, oh, there's only one that's extending now. So this would be extend from if we start at Q0. Yeah, and it is actually correct. So extend from Now we can do extend 2. That would be the other one, the other side of the line. So now it starts at this point, but it continues here. And the same thing applies here. Extend from, and then the other one is 2. Yep. Everything work. Although I don't want any extension at all in this case. But hey, it works. So now I want to draw a tangent line. 2 tangent lines even. So I want to add a line that is just 1 point. So 1 point, and then in this case I do want to extend it. What did I just delete? Extend. Is it not? Line extend. Yep. Plot line extend. Yep. And then both sides, so just extend. So this one must be going through point 1. I have another one that goes through point 2. But we have to pass the slope. Or at least, do we pass the slope? No. We don't like passing slopes. We pass 2 other points, which gives me the slope, or well, the direction anyway. And the other 2 points are just these 2 points. Let's change the dashes a bit. 5. Need an add line that takes 3 points now. And then, yeah, do its thing. No, I don't want to pass point. Well, I could start with that, but what I really wanted was to draw the actual tangent line. So then we have to pass a point 1 here, and then a tiny little vector, just a vector. I could just pass a vector that points in the right direction. Maybe we should just pass on normal. Pass on normal, yeah. Of course pass on normal. Way, way, way better. Let's pass on normal. No clue what the normal is yet, but hey. Let's pass on normal is 2 doubles, why not? Not a point. So that would be then yeah, not easy, man. Yeah, which is 0.02. Feels like it should negate this. Let's do that. So I'll do the difference in the y values when x is a little bit larger and x is a little bit smaller. And then minus that. That should be the normal vector at that point. And the same thing again, but in point 2. Okay, and now we have to add that. Add line. Where's my plot? Add line, which now takes 1 point and 2 doubles. Double, which is an x and double in y. And then code duplication. Ugh. Yeah. This defines the line, the first line, and then that's just the surrounding thing to calculate intersections, which might not even be necessary. Now maybe I should only calculate the intersections when there is something to something that uses the result. Like a line extend is not extend none. Damn it. I don't want to do this, but Let's make this an enum class already, man. Yeah. What? Yeah. Looks like the tangent is correct, just not going through P2. And this one is not going through P0, but if it were, then it would be a tangent line, I think. Also very interesting is to see that indeed these two are parallel. Like by eye, I would say exactly parallel. Why is it not going through that point? That is unclear why. I should be projecting the P0 on top of the line through the normal, which totally should do it. So I don't know. I guess I do the projection wrong. It's like, yeah, probably. What else? What else could it be? Last time I just had to add a minus, so let's just add a minus sign. That should do it, right? Yeah, wrong window. Yay, and it works. Brilliant. So I have a tangent line through P0, tangent to the curve here as well. And yes, you can see that the slope of this line is like exactly the slope of this line. So we can use Q0 and P2 to calculate, to know the slope in this point. And likewise there, and then calculate that point here, which is on P1. And then draw the Bezier curve for this piece. So I'm drawing this Bezier curve using 1, 2, 3, 4 points on the curve. Yes, thank you very much. On the curve. You just don't have to make the mistake that you draw this part as well, just this part. And then in order to draw that part, we need the next data point. I should go to bed. It's almost 1 a.m. Now, what is an easy way to calculate this point? Or is there no easy way? It's an intersection of two parameterizable lines. Let's make the thing bigger. What about 1200? Make it 900. What kind of value is that? Yeah, strange. Wouldn't you like to be able to change the color just by adding parentheses here? But yeah, and then how do we know what changed? So there should be something with weird values, and then only the ones that get specified are picked up and changed, something like that. So that would be a weird default then maybe. Although what is weird? Color transparent is weird. So line style. Could do transparent and then a line width of 0. Oh no, man. It's a bit dirty. Would be a bit dirty just to achieve this way to be able to do it. So the other way is to just set it here. Which is maybe better after all, if it compiles. Line color, yeah. Green. Red and green, yes. Okay, we have to make those lines thick because you can't see anything here. Line width is 2.0. No, not bad. Already have red point, so let's make the color something else than red. Purple. Don't have purple, dude. Why? What do we have? Yellow, blue, green. So to Nou ja. Yeah, okay, so I need a way to calculate that intersection there. I'm gonna ask ChatGPT. Let ChatGPT fuck up again. The direction vectors are nowhere to be found. Well, it's here, but then it fills it in. through P2 in this direction dB, Bs is P2 plus S times P3 minus P1. Okay. Step 3, intersection point. To find the intersection point P, we need to solve for T and S such that AT equals BS. Since these are lines in 2D or 3D, no, 2D, we can equate their components and solve the system of equations. However, giving the parallel nature and specific points through which they pass, we can use a more geometric approach. I should have told it that it was 2D, I guess. Yeah. Geometric approach, vector addition for intersection. The intersection point P can be reached by traveling along line A from P1 and along line B from P2. These, since these lines are parallel to lines that you can express P as P1 along the direction of P0, P2. Repeat what we already said before. Yeah, now we already had that, but now we have a, what is this? A lambda instead of a T out of nowhere, but for the rest, no change there. And here a mu instead of S. It's kind of not making progress. Equating for intersection. At the intersection, these two expressions must be equal. So that equals that. I agree. To solve for the lambda or gamma, what is it? Uh-oh. Think lambda mu, you would typically use the components of the vectors and solve the system of linear equations. However, without loss of generality and for simplicity, we can observe that the intersection point P must lie on both lines. Oh, really? And due to the parallel nature, we can deduce the relationship between geometrically or algebraically by solving the system. Lots of blah, still no progress. Simplification. In many geometric situations, especially when dealing with lines defined by points and parallelisms, solution might not require explicit solving for parameters, but rather understanding the geometric construction. The intersection point P will be where these two lines meet. Yep, it keeps repeating and circling and avoiding the answer. The conclusion, I don't know what the answer is. Yeah, okay, well, that's no help. The points are all 2D. All 2D in one plane. The points may be assumed to be all linear independent. Please give P expressed in the other 4 points. Just to repeat my question. And does it all over again. Hopefully this time we get a little bit further. Oh, even that is repeated. Yeah. No inside. No, it's the same question, same answer. That's my formula. Thank God. It's gonna go again. Oh yeah. Yep, still no formula. It can't do it. It also cannot tell me that it can't do it. It's pretty annoying. I'll have to do it myself. Paper. This time we have a nice graph. So the question is express this point here in terms of those other 4 points. No, that's indeed easy, I think. This is parallel to that one, this is parallel to that one. Therefore, this vector from here to there is the same as the vector from here to there. So in order to find this point, we add this vector to P0, which is the same as adding this vector to P0, which means we have to find that cross point here and then subtract that from P2 and then add it to P0, which means that it is P0 plus P2 minus this point. Yeah. So now we have to find this point. And that point we can find by let's ask ChatGPT if it knows that. Whoops. Okay, so wait, oops, you have no clue. So I will help you. Since let the lines be 0. That's hardly nice. Can I just copy this? Yep. No. I need a sub thingy. Yeah, I don't have everything, I think. So let's do a little bit. And P. That's not what I wanted to type, but okay, where's my sub? Sub 2. Never going to find a sub 3, I'm afraid. UTF-8 subscript 3. And there we have it. Let the lines P0, P1. That's not what I meant, right? I meant, of course, these two. P0, P2. P2. P1. Intersect in Q. Since What else the difference between a parallelogram and a rhombus? None? Oh, rhombus has equal sides. Okay, so it's a parallelogram. Parallelogram. No, I don't need the name. Or maybe I do. Yeah, it's a big formula, yeah. Yeah, shocking. It's just, why is it so difficult? Ridiculous. Right, okay, I think it's time to go to bed. I'll just have to work this out. Right, I've functioned for it. Yep. Well, if you tell ChatGPT that it doesn't, clearly you have no clue. That pisses it off. I'm sure of it. So I just had to show that it knows this formula. No, okay, nice. Except I can't copy it. Still hardly copyable. Yeah, okay, I'm gonna go to bed.